Hello and welcome to the after work video. In the last video, we learned more about the concepts behind, community, BGP communities, what they're used for. So they're just used to make decisions based on a label that you will assign to your routes. Since BGP is a border gateway, eBGP or an EGP, exterior gateway protocol, you're going to be handling a really large amount of routes. So that's kind of the purpose of BGP, is to be able to handle large amounts of routes. So the reason you would want a BGP community is so that when you have that many routes, you will want to put them into groups and apply decisions to whole groups of routes instead of each route individually. There's just too many to manage on their own individually, so you put them in the groups using communities, and then you can take actions based on the community that they belong to. So let's go ahead and continue with typing in the configuration. So router 1 is complete. So let's move on to router 2. Oops, and this is, okay, yeah, so router 2. Okay, so here's the name of our policy option for the communities. So the actual community strings themselves are going to be right here. But we're going to accept any routes that have any of these community strings. And these are because they're members of this community 1. Okay, I'm going to take a closer look at some of the options here, because this is to edit routing options static. So what I'm more familiar with is the static route, where you would actually add a entire route. So like, let's say 10.10.10.0/24. But then what I'm more familiar with is you would just add the next hop to it. So it looks like there's, okay. So yeah, you would just, oh, and my thing went away, but I'm more familiar with advertising out a static route that includes the next hop. This looks like they don't have next hops. They just say whether or not to reject or install them. And then those are advertised out into BGP, I believe. Where's, yeah, statics right here. So they're exported into BGP. So you don't need to include the next hop because the next hop is going to be the local, it's eBGP. So our local autonomous system is 2, PRAS is 1. So the next hop is going to be the exiting interface here, which is going to be .2. And we'll be able to see that. This is a really nice and clear example with where Wireshark captures will be really easy. Perfect. Okay, so before I commit this, I actually am going to bring up the Wireshark Capture now, and then we'll see. One thing I'm going to do, though, is prevent that race condition just because it clutters up the Wireshark Capture. So I want to make it nice and easy to see the things that are happening and not look at any red herrings. So I'm going to make this side, router 2, the passive neighbor. So we're going to avoid that race condition, all that clutter, extra clutter, and make it a lot easier to see what is happening in the Wireshark capture. So I will start the capture before I commit, and then commit. Perfect. Oops, and for some reason I'm not getting anything. Let's see if the BGP neighborship is established. Nope, it's still inactive. So let's see if I can ping across the link to that neighbor. I can. Interesting that the ICMP is not showing up. Let's get the capture rerunning because the ICMP didn't show up, so I think there was an issue. All right, hopefully the ICMP traffic will show. There we go. So now things are definitely capturing, but it is inactive still. So let's take a look at the configuration. So this is address .2 with a neighborship to .1. So let's see what this is configured as. This is address .1 with a neighborship to .2, and there's an import policy applied to the neighbor. So, oh, I wish I had my phone on me. It's over there. I'm gonna grab it quick. Okay. All right, so everything is, so I guess it just took forever because I can see some messages there. Show BGP summary. Yeah, it's in established now. So I don't know what took it so long, but it's in established now. We can see SYN, SYNAC, AC. And we can see the open messages and now the keep alive or the update messages. These are going to be affixed with the community attribute. So it's going to be under path attributes. There we go. So this route, network layer reachability information, these two routes, .2 and .3, belong to these communities now. Optional transitive. And we can see that's because, and yep, so they originated from AS2 and the value is 3. So let's take a closer look at that. So we can see from, so statics, from protocol static, then add route. So that's why we can see that each, these path attributes, all of these communities apply to each of these routes. It's because in our policy, we take all of these communities, and then we say from protocol static, so these routes here, we're going to append these communities onto it. So it's going to have all those communities, and then we're going to accept it. So here it is, the results of the fruits of our labor. And then, as I was saying before, since it's eBGP, it's going to use the next hop. Well, actually, since it was originated on this device, and even if it weren't, and it were going through an eBGP link, if it originated on IBGP link and then going over to over a eBGP connection, it would change the next hop. It only doesn't change the next hop if it's going through IBGP connections, but it's going to use that selection process, and it's going to end up choosing the outgoing egress interface. So that's right here. So that we see that, yep, that is what it used for its next hop, but the next hop attribute is a well-known transitive attribute. In this case, because it's eBGP, I believe. I think that would be different if it were IBGP. So one thing that's interesting to notice is that all of these are transitive attributes. Well, that makes sense, because if they were non-transitive, would they be sent across a eBGP connection? So I'm going to keep an eye out for that, and be extra sure to kind of check that there, because if I see a non-transitive attribute sent across an eBGP connection, I'm going to need to kind of check my learning and do some more reading and make sure I understand the meaning of the word transitive and non-transitive when it applies to well-known BGP path attributes. The way I understand it now, transitive are sent across an eBGP connection, non-transitive are not. And I actually will take a quick look into that right now. So this is the wrong, because I already got the RFCs pulled up. So transitive. So let's see, we got 26 matches. So yeah, I don't see anything like really clear about what transitive versus non-transitive means. It's kind of hard to tell, but as far as I understand, it just means whether or not it's sent to other routers. And I think it means more than that. It means whether or not it's sent to eBGP or iBGP. But let's look it up. BGP, well-known transitive. And hopefully we can get a good educational material. So this looks good from Cisco Press. So here we go. Oh, what? I guess I'm really surprised to see this being called a transitive well-known, because I thought transitives were either optional, like it would be a transitive optional. Like if you had a well-known, it would either be mandatory or discretionary. It wouldn't be transitive or non-transitive if it were well-known. So maybe I need to specifically look at Juniper's. This also looks good too, the Kevin Wallace Fundamentals of BGP. So yeah, I'm gonna read this whole thing because this looks really good. When your BGP speaker receives a BGP prefix, there are going to be many path attributes tagged to it. And we know that these are going to be critical when it comes to BGP doing things like choosing a very best path to a destination. Interestingly, not all of these path attributes are created equal. All BGP path attributes fall into one or more main categories. Note that this list also provides example attributes in each category. Do not be too concerned with these specific attribute values now, as you will understand many of them fully when you complete this blog series. Well-known mandatory, well-known discretionary, optional transitive, optional non-transitive, even though it's saying that this is transitive, well-known, complete, whatever that means. So optional, transitive, yeah, I don't know where it says anything about well-known. Oh, maybe this is just telling you what the options are. You can have it transitive, well-known, complete, but you can see it's only I'm not sure. Notice that two of the categories begin with the term well-known. Well-known means that all routers must recognize this path attribute. The two other categories begin with the term optional. Optional means that the BGP implementation on the device doesn't have to recognize that path attribute at all. Then we have the terms mandatory and discretionary associated with the well-known term. Mandatory means that the update must contain that attribute. If the attribute does not exist, a notification error message will result, and the peering will be torn down. Discretionary, of course, would mean the attribute does not have to be in the update. With the optional attribute categories, we have transitive and non-transitive. If transitive, the device needs to pass that path attribute on toward its next neighbor. If non-transitive, it can just ignore that attribute value. So yeah, it doesn't really have to do with iBGP or BGP. It just depends on whether or not it is passed to the next router. So if it's optional, that means that the router can decide whether or not, let's see here, so well-known. So optional means that the BGP implementation on the device doesn't have to recognize the path attribute at all. So it can take it, it can leave it, but if it takes it, then if it's transitive, that means that it's going to pass it on. If it's non-transitive, it means it's just going to use it for itself. All right. Example 1 shows okay, yeah, we need to look at example one. But yeah, so this makes sense. So if it's well known, that means that the router can't ignore it. It's well known. It's something that everyone does, that the router is going to do. It's not going to ignore it. If it's optional, then the router, like, yeah, it can do something about it. It can take it or leave it. It doesn't. It's not a big deal. If it's mandatory, so then it means that every time, then it means, so mandatory means that the update must contain that attribute. If the update does not exist, a notification error message will result and the peering will be torn down. Discretionary, of course, means that the attribute does not have to be in the update. So these are like the bones and muscles and brains of a BGP update message. If you take them out, the peer session goes down. You have to have the origin, the AS path, the next hop. Those are all well-known mandatory attributes that must be included in the update message. So let's go and look at the update message. And we're going to see all of those in there. So let's do BGP dot update. Path attributes, or is there no, yeah, so all update messages that have path attributes. So it looks like there's only one, which makes sense. But we're going to see in here that it is including those well-known mandatory BGP path attributes, because as I said, those are the bones, those are the brains, those are the muscles. If you didn't have that in there, you wouldn't have a peering session. So, well-known mandatory, from this chart, it looks like we've only got 3 of them, and that's origin, AS path, next hop. Those are the meat and potatoes, the absolute most important things about that need to be included in a BGP peering session. They're well known and they're mandatory. So that means a router has to use them and it has to be included, or else it can't be passed on. So the origin, the AS path, and the next hop, there they are. So plain as day, 1, 2, 3, they're even in order that they're listed there. These are all well-known mandatory things. So, all right, so let's think about the next level of things. So well-known, discretionary. So these are the things kind of like, you know, it's nice to be, to not be obese. You know, it's nice to have nice looking hair. It's nice to be athletic enough to run a fast mile. It's nice to be able to fit into a particular pair of pants, but it's definitely not mandatory. You're going to survive if you don't have it, but it can just be nice to have. So these are well-known discretionary. So discretionary would mean that the update does not, the attribute does not have to be in the update, and it can still form a peering relationship. So optional is just, so optional means that the BGP implementation on the device doesn't have to recognize the path attribute at all. So whether or not I'm wearing a watch, whether or not I'm wearing brown shoes or blue shoes, does not necessarily have to, you know, mean whether or not I can enter the club or not. So if your club says we don't allow wristwatches, I won't be able to enter the club. But it doesn't necessarily mean that I can enter or not. It depends on more than that. Now, if I'm missing a well-known mandatory attribute, such as I don't have a brain or I don't have lungs or a heart, yeah, I can't enter the club then. If I'm missing a well-known discretionary attribute, like my IQ is 40, well, I can probably still get into the club, but I don't know how much fun I'll have in the club. That's probably not the best example because there's probably good reasons to not have a well-known discretionary attribute, where there's not very many good reasons to have a IQ that low and want to go to a nightclub, I think. Well, I don't know. I'm not here to judge. This is not a judging channel. This is a JNCIE-SP network engineering channel. But I think that's definitely a really good example when it comes to understanding these. Well-known mandatory, yeah, if I don't have a brain, if I'm not alive, I can't go into the club. Well-known discretionary, well, you know, they might not want people like me in their club. Well-known transitive, well, they, or optional, you know, maybe they don't allow blue shirts in the club. I can go home, I can change my shirt. It's not a big deal. It's not about me. It's an optional attribute. It doesn't have to be that way. And then transitive would mean I'm going to, let's see here. If transitive, the device needs to pass that path attribute on towards its neighbor. So in order for, okay. Yeah, if non-transitive, you can just ignore that. So I think I'll just kind of leave the analogy aside. Comment below if you can think of a really good one for that, to like a mnemonic to help remember that or help understand that better. But for now, I think I'm just going to move on and finish this exercise. But it's definitely interesting. And we know that if we ever see a notification error, we can think, oh, there might be an issue with those well-known mandatory attributes, as we saw before where there was an issue with the next hop, because that is a well-known mandatory attribute, as well as the AS path and the origin. And we can see that here. Origin, AS path, next hop. And then the community, that is going to be an optional, and it's going to be transitive, I believe. Yeah, optional transitive. All right, so let's go ahead and keep working on this. So I got all the configuration now. It was really nice and easy. So let's see if there's any step-by-step information that looks like it's important to keep in mind. So nope, so let's do the verification commands. So on router 1, show route protocols, BGP extensive, oops. Oh, it looks like I don't have, oh, there's no S. Yeah, and believe it or not, I don't download every little thing I see, so I'm not going to download this just because it has an extra S. And I don't even know, maybe their version has an S and mine doesn't, so I'm not going to download that. I will need to be troubleshooting why I'm not learning these though. So let's figure that out. So make sure my neighborship is up. It is. So show route receiving protocol, BGP, neighbor, oops, 10.0.0.2. So I'm not receiving. Oh, I am receiving them, but it looks like I'm receiving them as hidden routes. So they're not making it into my routing table for some reason. And I don't know why. I do wonder why both install and reject is in there. That is something I don't understand. So the next hop, maybe there's not, no, I do have a valid path to the next hop. So show route hidden. So let's see validation state unverified. Let's read more about that. Yeah, let's see what this says. Now these are actually in the routing table. Origin validation for BGP enables BGP to recognize when an autonomous system begins advertising all or part of another company's assigned network. BGP recognizes the error and responds in a way that avoids service interruptions. To configure, all right. Well, I'm going to move on from that. I don't think that has to do with why it's not being installed in the routing table. So let's look at some detail. Aha, so hidden reason, really nice and convenient. Yeah, good reason. I like using Junipers. A lot of the documentation is really, for the most part, pretty good. And you get these kind of plain English reasons a lot of the time. You just kind of got to dig for them. You need that extra hidden detail in there. But all right, so let's figure out why the import policy rejected this route. So, oops, and it's going to be rejected by import policy. This is going to be the import policy under BGP. So show different protocols, BGP, like no more. So here we go. Import policy, remove communities. So I don't think this is what they meant, because they don't want reject. They want the community, like in the Wireshark capture. They just want this path attribute removed. They don't want the route to not go in the routing table. So I think there's going to be an error in this documentation. We can submit a downvote for that once I figure out what it is meant to be. But for now, let's see what other options there are in the then, because I think they didn't mean to do a reject. They meant to do something else. Let's see what that might have been. Aha, yeah, there it is. So community, delete. This is what they meant. Name to a set then community, delete, wild. I think this is what they meant to do instead. So yeah, so delete then reject, show pipe display set. So yeah, instead of having a policy applied to the neighbor, an import policy, because remember, import is talking about putting something in the routing table from a routing protocol. Export is putting something into a routing protocol from the routing table. So this is going to be applied before the routes. So if I do a run show advertise, show receive, show route receive protocol BGP 10.0.0.2, well, hidden. So before these can make it into this table, right now they're in there as hidden addresses. They're actually not in there right now. They've got to make it through this import policy. And you can see they were rejected by the import policy because I get a nice, clear show route protocol BGP detail. Hidden. A nice, clear reason for why it's hidden, rejected by import policy. So if I look at that import policy, it's remove communities, which from term 1, so from BGP, which are those routes we saw up here, we're going to look at the, so what it was originally, and I'll do a rollback 0, and then another there, and now we get the original configuration. So originally what we had was community while delete, and then we had a then reject. So I think this then reject is not what they want, because they still want to accept the route. They just don't want the community path attributes to be a part of it, the optional transitive attribute. They actually want to prevent it from being passed on to the other routes, almost as if it were non-transitive. But since it's transitive, you have to use a special policy like this. It's just, instead of rejecting the route, you're going to accept it, but it's not going to have that community information on it. So I think I'll probably submit a downvote for that if I really figure out that is in fact what they meant. Let's kind of, so this is on router 1. So let's look over the configuration of router 1 more. Oh, okay. So I missed a line. So that line's going to make a big difference. So yeah. Okay, good. That's always my preferred situation, is I just misread the documentation instead of there's an actual error in it. Okay. Okay, so now we're gonna set accept, and then we're gonna use another term to reject it. So delete, reject, up, set, and a whole nother term, set term 2, then reject. So show pipe display set relative. So we've got protocol BGP, community delete wild, then accept, then reject. So everything looks good there. Top, commit, and quit. So now it's going to look a lot more like it will look in the verification, hopefully. Oh, and there's no S in my implementation. Perfect. So now we've got the route. We've got all the routing communities, I think. I actually don't see them. Oh, yeah, we won't see them because we added the route to get rid of them. So if I deactivate that statement, then we will see them. That's what this is showing. So let's take one more look at this, and we can see there are no community attributes. So let's go and deactivate that configuration. Oops. Policy options, policy statement, remove communities, term 1, deactivate, then community delete wild. Now here's another thing that I don't think is worth a downvote. You actually can't do a commit under a hierarchy. You can only do it at the top. So if I try to commit this right now, can only commit from top of private configuration. So if I were being super strict, and you know, if I worked for the Juniper documentation department and I saw this, yeah, I'd probably take issue with it. But just as someone outside looking in, I know what I need to do. Just go top and then commit. It sucks for somebody new to Juniper, but somebody new to Juniper probably isn't going to be looking at BGP community attribute path attributes. So this is advanced documentation for advanced users, so it's not worth a downvote. All right, let's see those BGP community path attributes and the fact that they're now a part of this these routes. Yep, there they are. So you can see that the import policy was successful. The other thing that will be interesting to look at is a Wireshark capture when I reactivate that. So I'm going to take a guess from anyone who might be watching as to what you think might happen in the Wireshark. So why don't you take, so pause the video, 3, 2, 1. Okay, so now hopefully you have thought about what sort of thing might happen in the Wireshark capture. You might think there's going to be an update message. You might think about what might be in that update message. So let's take a look at when I reactivate it and see what happens. And then after I do this, I'll ping it just to verify that it was actually capturing. So there's some ICMP, so sure enough, it was capturing. So let's see that update message. And we got no update messages. And that makes sense because remember, the import policies are for routes coming from the protocol to the routing table. So the routes already made it to the device. So if we're capturing communications between the device, we're not going to see those path attributes being added or removed because that happens on a single device as it's being moved from the routing protocol to the routing table. So we're not going to see that. Where we would see those being added or removed is if I went on router 2 and I did configuration that added or removed those routes, those path attributes, we would see an update message in that case. So I'm going to do that. So configure private, and this statics, I'm going to go in the statics and I'm going to remove this line and commit. And now we'll see an update message, assuming it's still capturing. So I've got R1 still open, so I'll see if it's capturing by doing another ping. Nope, stopped capturing. So I'll roll this back and commit, and then restart the capture, and then we'll see in this case, sure enough, there's going to be an update message because we're talking about exported traffic. So it's going to export from the routing table to the protocol, and then it's going to be set across the link, and we're going to be able to intercept it because we're sniffing that link. But if we're talking about something being imported from the protocol to the routing table, it had already made it across that link. So we're not going to have a chance to capture that process. You probably could do a TCP sniff on the link between the control plane and the forwarding plane and see something like that. That would be, I'd be curious to look at that, but for now, let's focus on this rollback here and take a look at that update. Here it is. So we're going to see our path attributes no longer include that optional transitive attribute of the community. It only has the well-known mandatory. So let's add that back in, and we'll see another update message. And the optional transitive information for communities will be added back in. And then if any of these were missing, we would see a notification message, these three here. All right, so I think that's about it for this exercise. Yep, so it looks like there's another exercise, and it looks like it's the same topology, so I won't need to break anything down. I could probably just go right into it. Let's see what it's about. So it's configuring a routing policy based on the number of BGP communities, whereas this one is configuring a routing policy that removes BGP communities. So this is going to be a bit different. I would like the practice of typing out all of the configuration again. So show configuration type. Oh, right, because I'm in a different mode. I'm in config mode. Okay, so run show, oops, show, oops, show system rollback, or show system commits. So there's only been 7 commits so far. Let's take a look at show system rollback, compare 6 to 0, see what happened. Or let's see what happened from my 7th to my 6th commit. So in my 6th commit, I added well, let me see. Okay, so these were other. So I think these were on there before I started. Let's see what happened from my from the 6th to the 7th commit. I have a feeling that's when I deleted the default config and added the config specific to my needs. Okay, so I think I'm going to roll back to commit 5. There we go. So I'm going to get rid of all my interface configuration, all my routing options, protocols. So everything I just did, I'll be reverting and preparing for the next example. There we go. So I've got the basic config there. Show system commit. So it looks like from now I'll just roll back to 4 this time. So yep, I'm going to get rid of interfaces, routing options, protocols, everything. And then this will, blank config. Like I started with, I won't need to set up and tear down any more routers since the topology is going to be the same. So, but I think I will break here. This video is getting kind of long, and I want to definitely be able to give this next exercise its due credence. So thanks for watching, and I'll see you in the next video.